Welcome, class, to Chapter 9, Section 3, where today we're going to work on finding areas of composite figures. So, composite figures are any shape that's made up of multiple polygons. So maybe you have to cut the figure into triangles or rectangles or trapezoids and find the area of those pieces. And then when I add up all those areas of non-overlapping pieces, then I'll have the total composite area. So maybe I'm finding the area of a cone type shape, or I want to know the volume of an ice cream cone or a snow cone. Then I'd have to use the triangle and the semicircle. We've done things like this in the past in algebra or in elementary geometry, where they even give you the side lengths and you have to find the perimeter, adding them up. Or they divvy it up into little rectangles and little boxes here. This one kind of looks like a trapezoid and a triangle. And you even have the one that came from your benchmark. Here's a composite figure from your benchmark, where it gave you a semicircle and a trapezoid. You had to find the area of this panel, this side of the slide, and even do a little conversion from meters to feet. So we'll talk about that one in class too. So I have 3 examples for you. At any time, be sure to pause the video. You will have to sketch these on your own. And remember, the pictures are not drawn to scale. So if you're ready, I'm ready. And let's start with the first example. All right, so let's find the area of this shaded figure. And be sure to pause, give it a little sketch, come back and start at any time. And I'll just keep working. So you'll probably need a calculator too. All right, so I have a circle. I can find the area of a circle. And what looks to be a square kind of overlaps. So we're going to have to find the area of this section too. And what are we going to do? The easiest way I found to do this is go ahead and label all your parts. So if the side of this square is 20 meters, then this is also going to be 20 meters. And now I have the area, or the radius, and from the radius I can find the area of my circle. So I just need 20 squared times pi. I'm going to leave it in terms of pi for just a moment. And this would be the whole circle. If I want to find the area of this square, remember a square is just base times height, so 20 times 20. And now I have the area of this square, but I don't want this piece that's kind of overlapping. Remember, we said we only need the parts that are non-overlapping. So in order to help me with this, I'm going to think about this much of the circle, and then I can add that to the complete area of the square. So this much, if I go around, is going to be 3/4 or 3/4 of the circle. And I know that because I have a little right angle here. And if I divide 360 by 90, or subtract the 90 from the 360, then I'm left with 270, or the 3/4 of it. All right, so if I want to take this 400 pi, cut it into fourths, then that's 100 pi. And now I only need 3 of those, so that would be 300 pi. And I'm sure many of you answered that without doing the little simple work. So 300 pi is all this section over here, plus the 400, plus 400. And if I wanted to leave it in terms of pi, I would have to leave it just like this. I can't combine it and say it's 700 pi. But since I want a rounded type answer, I'm going to throw it in my calculator. And I'm going to round this to the nearest hundredths. So I get 1,342.48, and then my units are meters squared. All right, so if at any time you need to replay it or pause it, go right ahead, and I'm going to move on to example number 2. All right, here we go. Example 2, find the area of the shaded section. This time I have a regular triangle, or an equilateral triangle, and then it has a hole punched in it. So I'm going to have to subtract this area of the circle. So I'm finding the area of a triangle And then I'm going to have to subtract the area of that circle. And then that'll give me the leftover, all this shaded section out here. All right, so let's go about. Area of a triangle I know is 1/2 base times height. Area of a circle is pi r squared. So let's see what we're working with. Okay, I know I can find area of a circle really easy. That's going to be 36 pi. I know 1/2 is 1/2. The base of this triangle, that's going to be nice and easy. That's 36. The height, that height in there is going to be a little bit tricky. That's this height. If I drop it in right here, here's my height. So I may even have to do some trig functions or some special right triangle things. So let's see what we have. 36 divided by 2. I know this piece of the triangle is going to be 18. Oh, I can do Pythagorean theorem. 36, that's my hypotenuse, squared minus my leg, 18 squared. And I get, this is what I put in my calculator. This would be c squared minus b squared. And I get 972. And I will have to take the square root of that. And I get about 31.2. Now I found the altitude, or the height of the triangle. So plug that into my formula. And I am going to have to round my answers. .6. That would be an exact answer because I still have pi. I'm going to finish putting it in my calculator using my pi key. So if you'd like to see that, using the pi key, not just 3.14. And I get 448.5 centimeters squared. 0.5 centimeters squared. Alright, so finding the area of just a shaded section where one piece is missing. So I have to do a little subtraction. Alright, and our last example, now this one was kind of a word problem, and I took out the important words, so make sure you pause, draw your picture, and we'll keep going from there. Alright, welcome back. Hopefully you have your picture all drawn and labeled. Remember, it's not drawn to scale. I just kind of sketched it out and labeled what I needed to label. But they told us a story about an unusual window being broke, and the replacement glass cost $8 per square feet, and the installation charge is $35. What's the cost to replace the window? All right, so we will need to find the areas of all the pieces, then multiply those by my $8 charge, and then add the $35 fee. So I'm going to find the area of these little triangles. Notice they match on this side and this side. So if I have a triangle 1 foot by 1 foot, so 1 times 1 divided by 2, and then I have 2 of them, so I don't even have to divide by 2. So this one has an area of 0.5 and 0.5. So my little triangle pieces, that's going to be an area of 1 foot squared. Then I have my circle, who has a diameter. This was the diameter of 5 feet, making the radius 2.5 feet. So I can go ahead and find that one. So I got 2.5 squared pi. And then, notice it's only a semicircle, so I will have to take that whole thing and divide by 2, cut it in half. And then I have this shape at the bottom. It's a rectangle, and that's just going to be base times height. So if the base is 3, and my height is 4. So if you want to pause and get these calculations, then you can add them all up. So I'm going to have 12 plus 1 plus my circle, which I hadn't put in the calculator yet, I apologize, times my pi. And I got 9.82, keeping it to the hundredths. Here's my calculations. And then I throw it all in, add it all up, and I get about 22.82 feet squared. Okay, I'm going to leave this up to you, and you tell me how much it's going to cost to replace the window. I went ahead and helped you found all the areas, and you need to tell me the cost. So I can't wait to see what you have, and I look forward to seeing you in class. Have a nice evening.